Hello, my name's Stuart Davey. I'm a Principal Solutions Engineer for Oracle MySQL. I work out of the EMEA geography, and today we're going to be discussing how we can connect MySQL HeatWave instances in the Oracle Cloud. This may seem a little strange because connecting should be simple, and it is simple, but what we have to remember is that MySQL HeatWave enforces good security practices, and so directly connecting to it from outside of the Oracle Cloud needs some thought. If you're inside the Oracle Cloud, it's a question of routing security lists, but if you're outside, we have to do something else. As such, the bulk of today's presentation will be spent discussing the various methods for direct connection, or at least connection that makes any intermediaries transparent to users and applications. I'll also be looking at some administrative tooling that similarly allows transparent direct connection. If you have any questions as we're going along, could you please put them in the Q&A and we'll deal with them at the end. So just so that we're all on the same page, I'm going to start by describing what we mean by MySQL HeatWave. MySQL HeatWave has three offerings, and they're all managed database offerings. The first is the MySQL database service, which provides standalone instances. The second one is a highly available offering formed from three nodes of the standalone instance, if you like. So there's three nodes there. When you have that high availability deployment, clients connect to a VIP, and then the VIP routes the connections to the primary node. In the event that the primary node fails, then the cluster will fail over to one of the surviving nodes, and no data will be lost. The final offering is MySQL HeatWave. This serves both OLTP and OLAP workloads, providing super fast real-time analytics, as well as a machine learning capability. So we've just introduced that there. So that machine capability learning capability is really there for everybody rather than just the domain of data scientists. The final point to note on this slide really is that connectivity will be the same in all three cases, regardless of not whether we connect to a VIP or a standalone instances VNIC. Okay, so now let's get on with the meat of the subject and try and understand what the problem is. What's stopping direct connectivity to the database service? So let's step back a little bit in history. For many years on premise, we've always considered it best practice to deploy the data service tier, or the database if you like, in a private subnet, firewalled off from an internet-facing public subnet. The internet-facing public subnet typically hosted web and application servers, and so generally you'd connect to your web and application server, and then your web and application server would connect through to your database. There would be that demilitarized zone, if you want to call it, in between you, in between your database and the outside world. And there's still no problem with that model at all if you're going to deploy all of your application servers and web servers, everything else within that public subnet. But the world we live in today means we're dealing with hybrid clouds, by which I mean some of your applications going to be on-premise, some's going to be in a cloud, another part of your application might be in another vendor's cloud, and you then want to connect to an Oracle cloud for the database side of things. So that's the kind of issue we have. And as soon as we have that issue, all of a sudden is we can't directly connect to our database from outside of the Oracle cloud. So that makes things kind of difficult for things like applications where you've got a connection that's just trying to get to your database, but it's being beaten by firewalls or security lists in the case of the cloud. So if you look at the left-hand side, you can see that if you just tried as an application to come in from outside of your customer tenancy, outside of the Oracle cloud, if you like, you won't get to the MySQL database because you have no routing through to the private subnet directly from your application. So, we're clever people, we can try and work around it. Let's shift the MySQL database service into a public subnet. Unfortunately, the MySQL implementation defeats us there, because all the MySQL database service will have is a private IP address. So even if it's got a public internet-facing type of IP address on it, it is in fact on a private IP, a private VNIC, so you still can't get at it directly from outside. So how do we get around this issue? Well, there are a number of solutions that can help us get over this problem, and there isn't just one answer, because one answer won't fit all problems, or all particular circumstances. So I've grouped them into three sections here. The first set of solutions use an intermediary as a proxy, and this is basically either MySQL router or a load balancer. The second set of solutions use an intermediary server to achieve connectivity. However, the way these intermediary servers are used means they're completely invisible to the application or user. So from their perspective, the application or user's perspective, they directly connect to the database. The final set of solutions effectively merge your on-premise or other cloud vendor networks with the OCI network to create one super network. This allows us then to use traditional network routing to connect users and applications to databases. There's a good URL down here at the bottom that actually covers a lot of the information that I'm going to talk about now. So it's worth actually going back and having a look at this as well as what I'm talking about. So let's start off with using MySQL router working as a proxy. Okay, people might know MySQL router from InnoDB cluster, but we can actually also use it here in the Oracle Cloud to work as a proxy for us. So if we look at the illustration, the user or application connects to a MySQL router in the public subnet, and then the router transparently routes the connection to the database. As a consequence, we don't expose the database to the internet. The right-hand side of the slide provides the recipe for creating and using the proxy. It should be quite straightforward to follow. So I've put down all the stages that you need to do there. With respect to the VM, so you've got to actually create a VM or a compute instance, as we call it in Oracle speak, within the public subnet. So that's just a case of going through at the OCI console and creating a compute instance. The point to note is that if you want to save money here, if you're constrained budgetary wise, you could actually use a compute instance from the always free tier. So that would save you money. So that's the compute instance installed. Then once we got that installed, we install MySQL router and enable MySQL router. And then what we have to do is some work on the configuration of the router. And what we actually do is put in place a routing directive in the mysql router.conf. And I've put down a typical routing directive there. The first thing to note is the name of the routing directive, and I've called it routing:classic, purely arbitrary name. And the reason I've called it routing.classic :classic is you could also have one for the X protocol, which I'll talk about in a few minutes. Second point to note is the bind address. I've made the bind address 0.0.0.0 and then :7001. The 4 zeros effectively mean anything from the outside of the internet can bind to it. You might want to constrain that if you know exactly the subnet that you're actually going to be coming from, and use that subnet rather than such a wide address. The 7001 is an arbitrary port that I'm using on the MySQL router. You could use another number, but what you don't want to do is clash with a well-known port or anything like that. So 7001's good, 7002 is good, and so on. And then the destination is the destination of my MySQL database. So that's the 10.0.148 is the IP address of the MySQL database service, and 3306 is the standard MySQL protocol. Some other points to note there: you could have another directive in there that could make use of the X protocol, if you like. So if you were to use the X protocol, all you would change there is, well, you'd copy and paste the same thing, but change routing:classic to routing:x. Give it a different bind address to the classic bind address. So give it a different port, I should say, to the classic port. And also on your destination, change the 3306 to 33060. Once you've done that, you can start your MySQL router and you're up and running. Okay, make sure you've opened up the router ports on the security list. So if you're using 7001 and 7002, do that bit of systems administration there. And also, if you're on a VM that's a Linux VM from Oracle, it will have its own host firewall. So you'll have to use the Linux firewall command to open up the ports on the virtual machine as well. Once you've done that, all you do as a user or as an application is you connect to the router. Okay, so effectively that's the IP address of the compute instance. And I've shown MySQL Shell there. Other clients that are available, and again, in one form or another, you'll use the same components, say the username, the compute instance IP address, and indeed the port. So very, very simple and very easy to work. Again, you can make those proxies highly available if you wish. You've got to do some extra administration work there. The second version is pretty similar to the first version, but instead of a compute instance, what we're going to use is an OCI load balancer. Exactly the same kind of idea, but this time, as I say, we have to install a load balancer. So it's a case of going to the OCI console and working through that recipe that I've given you on the right-hand side. So going to load balance, creating a load balancer, and so on. Is there anything critical whether we really need to know about that? Now, if you just follow that recipe there, everything should be fine. And again, what we do when we come to the connection string, it's MySQL shell -- URL admin at IP address of the load balancer and the port number that you've chosen. So super simple. Remember to do the all the firewall, all the security list changes as well. But literally, you can get that up and running in 3 or 4 minutes, and it's there. It's super good for things like application server tiers when they need to actually connect to something too. And again, you can make the load balancers highly available if you wish. So that was the first group that we looked at, where we're using infrastructure as proxies to be able to actually affect a direct connection. The second way we can do things is by tunneling. What we're actually talking about here is SSH tunneling. So what's an SSH tunnel? Well, firewall, as we've already discovered right from the off, firewalling typically prevents external access to the database tier. SSH tunneling is a method that allows us to transparently go under these firewalls in order to reach our target database. In many ways, tunneling is kind of a romantic misnomer, because what we really are doing is SSH port forwarding. No firewalls are really circumvented, so we're not cheating the system. We're still going through those firewalls as before. But what we're actually doing is using an intermediate proxy server to relay the data or the command to the target database, and similarly return any response. Once you actually have set up for port forwarding or tunneling, if you prefer, the communication between the source and target is achieved without us having to actually knowingly use that proxy server. Yes, communications are going through it, but from the point of view of the application or the user, it's completely transparent. So all that you actually do on your client or your connection is your client is you actually connect to your local host and write to a local port. When you write to that local port, SSH is listening on that, and it says, okay, what I know I've got to do here is take that write through the tunnel and send it on to the database. And then clearly you've got the return traffic as well going that way. So effectively, the tunnel allows us to talk to the data, or at least it makes it look as though we can talk directly to the database, and the proxy server is completely transparent. So now we go on to how we can use SSH tunneling within OCI. So there's a couple of ways of doing this, and the first way of doing it is using something called the OCI Bastion service. The Bastion service is free and provided by Oracle, and it allows you to create SS tunnels by providing you the temporary use of an intermediate server. Please note the use of my word temporary there. You first create a bastion, but you can't use it until you create a session. And a session, once you've created it, has a time to live, and that session cannot be extended beyond its time to live. Okay. So let's have a look at the recipe for setting this up. Setting up the bastion itself is very simple. Make sure you're in the correct compartment in OCI. Navigate to the Bastion services pages as detailed there. So OCI main menu, identity and security, then Bastion. Click on Create Bastion. Thereafter, in the dialog, give the Bastion a name, select your virtual cloud network and your public subnet. The Bastion's then created and will be available for use and will stay there until you decide to delete it. But to use the Bastion, you have to create a session. Again, this is done in OCI by first clicking on your Bastion entry and then clicking on Create Session. When you create the session, you're going to get a dialog come up, and it's critical you choose the SSH port forwarding session. Okay. If you don't choose the SSH port forwarding session, then everything from there on will end in failure. So just make sure you click on that radio button for SSH port forwarding. When you clicked on that port forwarding, you'll get further entries in the dialog to complete. The first one is to enter the IP address of your database. Again, if you haven't got the IP to hand, go to the OCI console page for your database and look for the private IP address under endpoint. Then you enter the port number. Typically, this will be either 3306 or 33060. If you're using the X protocol, you will need 33060. Don't leave it at the default 22 in the dialog, because if you leave it on the default 22, nothing's going to work. Okay, so you've got to change the port to 3306 or 33060. Then you either generate a public private key pair, or you can reuse an existing pair. If you generate a pair, remember to download at least the private key, because you'll need to reference it later. And if you want to reuse an existing key pair, then either upload or paste in the public key. So it's as simple as that. Once you've done that, click on Create the Session. You're now ready to use the Bastion. So the first thing you've got to do to use the Bastion is create and start the tunnel. If you look over on the left-hand side, I show you how to start the tunnel. So you've got SSH -I, my key. So what I've just called it my key there, but that's the private key that we talked about earlier on. Then you've got two flags, the -N and the -L flag, to indicate that it's a local host. You then choose an arbitrary port number. You then give it the IP address and so on. Now this sounds quite complicated, but what's the nice thing about the Bastion service is when you've actually created a session, you can simply click on a triple dot menu item, and that will bring a drop down for you where you can copy the SSH command. So basically all you have to do is that, and you can copy the command in, and the only things you have to change on that command thereafter is the path to your key and the port number, as I've just described. Okay, again, the port number is an arbitrary port number, but it shouldn't be a port number of a well-known service. So you create the tunnel in a terminal. So if you're on Linux, it's just an ordinary Linux terminal. If you're on Windows, use PowerShell. Once you've created that tunnel, you then make the connection. I've shown the MySQL shell as the connecting client. Again, it could be any type of client. And again, it's very, very simple. All you have to do is give the database username, and the actual server name is known as localhost, because you're connecting to the localhost port of 3333. So quite simple. As I say, the downside of the OCI Bastion service is that it has a mean time to live of 180 minutes. So you really have to be quite careful on how you use it, because clearly if you've got long running sessions or anything like that, you're gonna get terminated. One way to overcome that is to actually create your own Bastion which is by creating a compute instance in the public subnet. So again, go to OCI, create the instance as you would normally. And then what you can actually do is SSH and go create an SSH tunnel through that instance. So again, what I've actually shown here is how to do that. The syntax is slightly different. You'll notice that we've got an OPC IP address for the virtual machine there. The OPC is the standard user for an Oracle Linux compute instance. Once you actually create the tunnel, the process is exactly the same. So now we come to VPN. So what's a VPN? Well, SSH tunneling does provide a direct connectivity solution, but it quite obviously has some limitations. For example, its usage is quite advanced. It may be okay for technical people such as DBAs, but it's difficult to imagine business analysts setting up tunnels using that kind of syntax. So an alternative is to use a VPN or virtual private network. It can be implemented in either software or hardware or a combination of the two. In many ways, a VPN does the same as SSH. It creates a tunnel and encrypts the data that passes through it, but it does go further. It's better at hiding where data comes from, but perhaps the biggest difference is where it's applied. The VPNs work at the transport layer of the network stack, so all communications from one endpoint on the internet to another will be secure, whereas SSH works at the application layer, so communications are secured on an individual basis. We've got a couple of options. We've got site-to-site VPN, which is the sort of more formal offering from Oracle, but you can also go to the Oracle marketplace to use OpenVPN. So OpenVPN, the great thing about OpenVPN is you get 2 concurrent VPN sessions for free, so you don't need to buy any license or anything like that. If you need more, then clearly you've got to license it. Probably best suited to individuals and smaller organizations. So how do you go about installing it? Well, go to OCI, go to the marketplace menu option, go to all applications. In the search bar, enter OpenVPN. When you see the OpenVPN icon appear, click on it and then click on the launch stack, as we can see there. Work through the resource manager forms. It's pretty simple. All the information you've got there is what you need to actually install it. Once you've installed it, you've got to do some security list updates. Okay, so we're going to be installing this in our public subnet. What you've actually got to do is open up the ports 443 and 943 for TCP and 1194 for UDP. Again, when you're opening up those ports, you can use 0.0.0.0/0, so that basically anything can connect, or you can connect from any IP address. But of course, if you know where your source is coming from, the sort of subnet you're coming from, you can secure that by using that instead of the 0.0.0.0. Once we've got that up, we can actually start administering it. How you administer a VPN server is to go to its browser interface. So it's just the IP address of the compute instance you stuck it on. All I had to do was make 2 changes. I'll quickly go to those 2 changes. I put them here on a screenshot to make it simple for you to understand. Then when we've got that going, we've just got to do the client-side installation. So we've just got to download and install a very simple program. Easiest way of downloading it is when you go to the server, whenever you go to the server browser interface, the first thing is you get is this sort of dialog in the top right that I'm showing you there, and that will allow you to download the client-side application for your particular operating system. Once you've downloaded it and installed it, you've got to import a profile. So the first stage there is, again, starting the client, you'll be prompted to put in the address of the server, and then the next stage will be to put in the user that you created in the previous stage on the server. Once you've done that, you can import it, and then you can start using it. To use it is as simple as start the VPN and click on this button here. So you can see the connected button here. Click on that to connect. You connect, and then you can start connecting straight to your database. So again, I'm using a client application here, MySQL shell, and you can see here, all I'm actually using is the true private IP address of the database. So it's really easy to connect. Super simple. The next thing I want to talk about is site-to-site VPN. Now, this is a much bigger sort of offering. It's the official VPN offering from Oracle. It's truly enterprise. Okay, so it uses industry standard security protocols, and it's really the difference between OpenVPN and site-to-site VPN is OpenVPN is really constrained to the device you're on, whereas site-to-site VPN is exactly what it says. It will connect whole sites, so all of your on-premise to all of your Oracle cloud. And so that's why you've got this site-to-site. You've got to do more work to set this up. You need to have hardware in your on-premise situation. So you've got to have switches that are VPN routers, for example, installed and everything like that. But it does provide you high availability. It does allow you to use protocols like border gateway protocol, so that essentially we can discover your all your networks in your on-premise automatically and so on. Don't have to use BGP. You can keep it to static if you wish, of course. As I say, it's proper enterprise scale. The nice thing about site-to-site VPN is it's free of charge, okay? Just like OpenVPN is free of charge. So all you need to do is install it and so on. And the other nice thing about Oracle is we have probably the cheapest data rates of any cloud. So you don't pay for any data until you actually reach a threshold of 10 terabytes a month. So once you've actually shipped 10 terabytes out of the Oracle cloud a month, then you'll start getting charged per gigabyte, as it were. There's no charge for data ingress. Compare and contrast with Amazon. They charge for everything. So this is how you install site-to-site VPN. You would use a wizard. I can't go through it all here because it's quite complex. You need to work with your network engineers, but you need to know all about that customer premise equipment, i.e. your VPN router switch, as it were. Some other considerations: you can deploy site-to-site VPN even if your customer premise equipment is all behind a NATed front end. One thing you really do need to be careful of is not overlapping CEDAR blocks, so not using the same addresses both on premise and in the cloud. I put an interesting blog here, excuse me, that tells you how to actually create a very cheap site-to-site VPN in your own house. I haven't tried and tested it, so it's a bit of a gamble, but it might be fun to actually try and do. The Rolls-Royce of all our solutions, interconnectivity solutions, Fast Connect. Again, this is probably for very large companies. We're very competitive price-wise, but it's not cheap, if you see what I mean. And again, it allows interconnectivity with Azure as well, so everything becomes seamless, and it's just a case of routing. Returning back to the SSH administration in general, MySQL's brought out tools that effectively make direct connecting easier. So, for example, MySQL Shell now has a built-in SSH tunneling capability, so you can actually do everything all in one command rather than having to set up a terminal somewhere to open up an SSH tunnel and then run a command. So it's much more convenient. The URL goes into greater details. And then we have Workbench. Again, you can connect through SSH tunnels, and it's all built in. I've put the recipe on the right hand side there for you, so it's very convenient. And coming soon is a MySQL admin plugin for Visual Studio. Okay, the nice thing about that is it keeps all your administration in one place then, so all your development work, you can immediately connect off to your database and so on. So in summary, I think with MySQL HeatWave, direct database connectivity solutions, we have something to fit all requirements and budgets. It's a matter of personal choice. It's a matter of what suits you regarding sort of usage profile. It's a matter of what suits you with respect to security. So I've put down here some ideas of the sorts of how and where to use certain solutions. So if you've got tiers of application servers, I would suggest setting up SSH tunnels is just it's just ridiculous. It won't work. You want to use something like either MySQL router proxies or load balancers. If you've got more money to spend, then you might want to consider site-to-site VPN, or even if you're at the high end, then it's just a case of routing with Fast Connect. If you just want to connect and administer a database from your laptop, use an SSH tunnel or an OpenVPN connection, or alternatively just use those tools that I've been discussing. And if you're kind of a power user connecting remotely with BI tools, OpenVPN connections might just be the best and cheapest solution for you there. And we do try and keep costs down. Most of our solutions where we've got to use intermediate servers, you can leverage the free tier. There's no charge for site-to-site VPN. And again, Oracle's data charges are very, very competitive. The first 10 terabytes being free of charge for egress. Inbound data is never charged for. So we'd like you to stay in touch and connect with us, and that's how you can do it. I don't think we've got any Q&A questions at the moment outstanding, so I'm just going to leave you there with a reminder of our next session, how to set up high availability and replication in OCI for MySQL HeatWave. That's on the 29th. I hope you found this session interesting. Please download the slide deck. There's a lot of information in there that could be very useful to you. Thank you very much for listening. Goodbye.